Hello everybody, this is my project for this week. So this one is a Lenovo 110S. Oh, what happened to my hand? Obviously could have doing something. It's an IdeaPad. So this, as you can see, has no screen. We've no charger with it. It's described as having a motherboard fault, and that's what I'm going to take a look at. So I'm going to flip it over here and we're going to get a look at what voltage we need to inject into this. So here we go, Lenovo IdeaPad 110S-11 IBR, 20 volts input, and it needs to give it up to 2.25 amps. So I'm going to take some pictures of the motherboard in this, and we're going to get a look at it on the screen.
As you can see, my scanner did a great job on scanning in this motherboard. Now, before I was going to go to voltage injection, I spotted two issues with this motherboard. So what I'm going to do is I'm going to set down a challenge here. I'm going to ask you all to get a pen and paper and write down the two issues that you can see with this motherboard. I'm going to scroll up this and see if you can spot what the two issues are. Okay, so I'm going to leave it on this section for a bit. The second section is right here. This is the third section. And this is the fourth section. Okay, so write down on a piece of paper what two issues can you see by visual inspection on this motherboard. Okay, we all ready? Well, the first thing that I found that was wrong with this was pretty easy to spot. So if you zoom in on this section here, we can see that four of the pins, maybe 4 or 5 of the pins on the connection that goes to our screen look like they are burnt off somehow. Okay, and the second issue, which is completely independent of that, is our main pin is actually broken off the DC jack. See it there? So that should be connected straight on here. So there's the two issues I spotted with the motherboard. So before injecting any voltage onto this board, I just want to see if I can find the path. We know our 20 volts should come in here, but I want to try and see if I can find the path from there and just make sure that there's no shorts before we start injecting voltage onto the board. So let's do that. I'm going to introduce my red probe so I can do a bit of pointing here. Well, our 20 volts comes in through our DC jack, and when our center pin is actually connected properly, it carries the 20 volts onto the motherboard right here. But where does it go from there? Because this capacitor is simply to keep our 20 volts stable. This is ground on this side here. If we look closer, we can see there are a number of vias, 1, 2, 3, 4, 5. So what we need to do is flip the board and see where these vias come through to the other side and where they bring our 20 volts. I've flipped the motherboard and you can see that that DC pin actually comes straight through to the other side. So we're effectively getting our 20 volts across our connection here and onto the back side of the motherboard as well. So where does it go from here? Well, we've got this big track here that carries it seemingly to a number of places across the board. Let's just have a look. Okay, so it's right across this path here, and it seems to come through on a number of spots with vias, particularly here where we've 6 vias. So it appears to go through to the front side of the board here, and it appears to go through to the front side of the board here. We also have these other vias, so presumably it comes through there as well. But what I'm going to do is I'm going to look for this 6 and this 6, and we'll just see if we can find where is the main path that our voltage is taken. So flip the board again and continue looking. Back to the front side of the board again, and we want to see where those 6 vias come through. So our first bunch of 6 vias is 1, 2, 3, 4, 5 and 6, which brings our 20 volts to here and to this IC. Our second bunch is 1, 2, 3, 4, 5 and 6, which comes to this current sense resistor right here. So we should be expecting that our 20 volts coming in here is then going here and then going here. So given that there's a current sense resistor here, I think this is the main path where it goes in, because obviously the system has a current sense resistor here so that it can measure what current is coming onto the board in case there's too much current, so that it can shut it down. That's the function of having one of these in line. But we know our 20 volts is coming to here, so what is this next component here? The next component in line here is sort of unusual looking. We're used to seeing 8-pin MOSFETs at this point, and usually 2 of them. But this has 1, 2, 3, 4, 5, 6, 7, 8, and seemingly 2 pins here as well. So, like, it's easy to get scared of these when you see something that looks a little bit different, but I expect that this is some sort of MOSFET. The beauty of the internet, of course, is we can take the number from the top of the IC, run it through Google, and find out exactly what it is, and that's what I've done. So if you take a look at that, that is an N-channel enhancement mode MOSFET, 30 volt. So the same function essentially as the other 8-pin ones that we usually see in this position. So if we take a look at the pin outs, we've got 3 source pins and a gate on one side, and then all of the pins on the other side, including 2 pins on this side and 2 on this side. They're all joined together and they are all drain pins. So what I'm going to do is I'm going to mark that out on the board now, just so we can see a bit more clearly what's happening. Okay, so with all of our pins marked in, it makes a lot more sense, doesn't it? So we literally just have 4 drain pins and 2 drain pins connected right here. Our 20 volts comes in this side, and then we have a gate pin here. So the gate pin controls whether that 20 volts comes through from our drain pins to our source pins and then onto this IC right here. It's just a slightly different shape. So if we've 20 volts coming in here, what would we expect to see on the gate for this MOSFET to be turned on? Well, I'm going to guess that we should have maybe somewhere between 24 and 26 volts or something like that. So we can measure that afterwards. But after this MOSFET, the voltage, the 20 volts, should then come through here and onto this IC right here. Now, I'm not sure what exactly this IC is. It seems like some sort of controller chip for input voltages. There's usually some sort of battery management IC at this point. But what I'm going to do once again is I'm going to look up the datasheet for this and see if we can find out exactly what the functions of this IC are. Now, this IC is an OZ8690LN. I was unable to find a datasheet for this. However, what I did find was this. And this can be useful at times as well if you don't find full datasheet. I found a schematic from another laptop that actually uses this OZ8690 IC as well. So what do we see here? Well, first of all, it's given me all of the pinouts, and it's given me a sample configuration. It's more than a sample configuration. It's an actual configuration, but just from a different laptop. So what we can see here is we have 5 pins here that are VAD, which appears to come from our DC in, so I think that's where our 20 volts will come in. We have a VBAT. Would anybody like to hazard a guess as to what VBAT is? Well, I would presume VBAT is the charging voltage for the battery. And we have a VSys down here also. So we have seen these type of ICs before in other laptops we've worked on here. So it takes an input from the mains, from our main power adapter, and it gives us out 2 voltages. It gives us a battery charging voltage and it gives us a system voltage. And then it has a number of pins for checking for feedback and over voltage, over current, etc., etc. And that's what the function of this IC is. So what we should be expecting is that, let me just work out the pinouts on this. So it's 11 to 15 is the input. Let's just get a look at that. Okay, so we've pins 11 to 15. That's where our input comes in. We know that already. So 20 volts in here. And then on our VBAT is 16 to 20. So 16 to 20, which is that these ones here? 16 to 20 right here. So we should be expecting to find our battery charging voltage right here. And then pins 21 to 26 is our VSys. So 21 to 26, which is 21 to 26. Thankfully, they've put markings on the board here to save us having to work it out ourselves. So this is where our VSys voltage should be. So what I'm going to do is, before injecting voltage onto this board, I just want to have a cursory look and just make sure there are no shorts. So I'm going to check for shorts just at each stage, say here, here, and then on our main VSys. So let's do that next. To make this a little easier to follow, I've marked out the pins on that IC. And I've just drawn an overview of the path in. So our DC comes into our current sense resistor, onto our first MOSFET, then onto our power management controller IC, and then our VSys is out here. So what I'm going to do next is I'm going to introduce my multimeter in diode mode. We're going to switch off all power to the board and start taking some diode mode measurements. So with my multimeter in diode mode, I place my red probe to the nearest ground, and I take my black probe and we're going to start taking some measurements. So the first place to measure is just after the current sense resistor here. This is essentially measuring the whole way from the input pin right to the first MOSFET. So when I place my probe to this side of our current sense resistor, I find that it measures 1.312. So this is certainly not shorted. Next I want to measure after this MOSFET. So I place my probe carefully to the source pin of this IC right here, and I measure 1.986. So that's a lot higher than some of the values we've measured before, but all I'm looking for here is to make sure there's no short. So that's definitely not shorted. And lastly, I just want to check our main VSys power rail just to make sure that this isn't shorted as well. So still in diode mode, I place my probe to, where's the easiest place? I place it to this pad right here and I measure 0.513. So it looks like whatever is wrong with this laptop, we certainly don't have a short on the input section. So I'm happy enough to chance injecting 20 volts. So let's inject some power onto the board and see what happens. So now that I've established that it appears there's no short on the motherboard, I'm happy to inject voltage using my power supply. So let's introduce my DC power supply. I'm going to put up a current limit of 2.5 amps on it, and we're going to inject 20 volts. So I connect my black wire to the ground, which the nearest ground is just the outer pins of my DC in jack, and then my red wire, obviously I have to connect it to the part that is connected to the board. I can't connect it to the center pin of this because, as we established earlier, this is broken. So I'm essentially hopping over the DC jack and injecting straight into the pin on the board. So with that injected, I took a look at the board. So let's go back to the real world and see what happened.
And this is what that setup looks like. So black wire connected to ground, red wire connected to the center pin of our DC jack where it hits the board, and we have our little crocodile clips connected here. And that's connected to my power supply, and I've put 20 volts into it. So it's currently drawing 0.009 of an amp. That's 9 milliamps. So that's about right. It's certainly not shorted anyway, because we would be getting far more than that if it was shorted. So let's try then and see what happens when we press the power button. Now the power button on this is not on a little daughter board or on a keyboard. It's actually on the board itself. So let's press it and see what happens. Okay, so we've got a light there, and as you can see in the background, it's starting to draw a bit more current, and we have liftoff. Now I powered this on already and it does come up to Windows. I just don't want to show the name, so I'm just going to keep this facing down here just to protect the person's privacy. But as you can see, it is powering on. When it's powered on with no battery charging, it pulls around 200 milliamps.
So when I inject power onto this motherboard and I use an external screen, it works. So the question is, what exactly was the fault with this? Well, what I'm thinking at this point is the reason that they decided not to repair this is because of this here. I'd say they tried replacing the screen or just took a look at the screen connector and said, no. And obviously because it's a small little laptop, you're not going to be bringing around an external monitor with you. I can use the external monitor for testing, but it's a laptop, you want it working with the screen. And if the screen connector is gone, I'd say they wrote it off once they saw this. What's curious to me is what happened with this here. Because obviously the screen connector having a fault does not directly lead to this pin breaking. I wonder, did this just break when they had it sitting in with a number of other motherboards or something like that? Was it physically damaged while in storage? It's just a little confusing, but I can get it to boot. It's not worth me replacing the screen connector on it, but maybe somebody has learned something from the approach that I took to trying to get this back to boot again. That's my project for this week, guys. Please like and subscribe. If there's anything else you want me to cover on this channel, post it in the comments below. And you can contact me on therepairshare@gmail.com. That's where I'm going to leave it for this week. And I'll be back with something new next week.